So this is the first example problem from chapter 3, which is energy. A horizontal force of 100 newtons is used to push a 20 kilogram box across a level floor for 10 meters. How much work is done? And then in question B, how much work is needed to raise the same box by 10 meters? Okay. So when we're talking about work, W for work, so don't confuse that with weight. This is work. Work can be defined as the force that's applied times the distance that the object travels. So in this particular example, part A, we have this box, okay? It has a mass of 20 kilograms. So that's the mass. And there's a force operating on this box. We're pushing it, right? How far are we pushing it? We're pushing it for 10 meters. So it's going to end up over here now. Okay, so your distance is 10 meters. Well, this equation for work is very simple. It just says whatever force is being applied times the distance that the object travels. So that would be 100 newtons times the distance that we travel, 10 meters. So that's 1,000 Newton meters, okay? Now, typically work units are either in joules or kilojoules. So let me go through here and say that 1 Newton meter is the same thing as a joule. All right, and in terms of abbreviating joule as a capital J, that's what we would use. So even though I've written it as 1,000 Newton meters, more commonly we would write it as 1,000 joules. That's the more common name for this particular unit. Okay, let's remind ourselves that the Newton is a kilogram meter per second squared. So when we're doing work, a Newton meter would be a kilogram meter per second squared times another meter because of the D, right? So you have a meter in the force unit in the Newton. So now you have 2 meters. So it's meters times meters. So that's a kilogram meter squared per second squared. Okay. So we could also, in this problem, we could also claim that the amount of work is 1,000 kilogram meters squared per second squared. And that would be correct as well. All 3 of those are correct. 1,000 Newton meters, 1,000 joules, or 1,000 kilogram meters squared per second squared, just because the Newton and the joule are based on combinations of kilograms, meters, and seconds. Okay. Now, part B says how much work is going to be done or needed to raise the same box by 10 meters. So now it's a little bit different. Now what we're doing is we're raising this box, again, same box, and it's got to get raised by a height of 10 meters. Okay, so H is 10 meters height, right? Okay, well, that's pretty straightforward as well, because the force needed to move the box is equal to the weight of the box. If you apply a force that's equal to the weight of the box, you will have the same amount of force as the weight of the box. If you do a little bit more, it'll start moving up. You can accelerate the box. So the weight of the box, this is from chapter 2. We said that that was mg, okay? And that would be equal to the force that you're applying. The force upward to pick that box up is equal to the weight of the box, mg. Now, if we want to calculate the amount of work, Well, that's just the force times the distance, but here the distance is a height. So it would be the force times the height. So mg is the force, h is the height, and there you go, mgh. Okay, so now we can go ahead and calculate that. The mass, remember mass is not weight, mass is mass. It's 20 kilograms. So now that's why they gave us the mass there. We didn't need it for part A, but we do need it here. 20 kilograms. G, remember what G is, right? 9.8 meters per second squared, approximately 10. And then we're going to multiply that by the height. It went up 10 meters, right? Okay, so that gives you about 1960. Kilogram meters times meters, so that's meters squared, divided by seconds squared. Or 1960 Newton meters, or 1960 joules, right? So there you go. So it takes more work to move the object against gravity than it does to push with a particular force to overcome friction and to overcome inertia and to accelerate this object in some direction horizontally. Okay, almost twice as much, right? About 1,000 here, almost 2,000 there.